So today we're going to learn how to write names and formulas for binary molecular compounds. And then just a reminder, another name for molecular is covalent. Okay. So you'll hear me call them molecular or covalent, like either or. So you just need to be familiar with both names. Okay. And these ones are completely different from ionics. Okay, so these have a whole new set of rules. The good news is these ones are much, much simpler. Okay. So first, what you really need to know for this slide is just the bolded words. So molecular or covalent compounds, they are just made up of two nonmetals. And then if we refresh, where do we find the nonmetals when we look at the periodic table?
All this area.
Good. Okay.
And the hydrogen.
The top right, do you see the bolded staircase on your periodic table? Okay. The nonmetals are on like the top to the right of that. Okay, so it's like the top right corner plus hydrogen, that's all by itself. Okay. All right, so then how they are different from ionics. What word do you know that's in ionic?
Ion.
Okay, ion, and what are ions? Okay, they have those charges, right? Positive or negatives. So ionic ones are the ones we worry about charges. Molecular and covalent don't bond that way, so there are no charges involved. Okay, so we no longer have to look at charges. We no longer have to do the crisscross rule, okay, which is going to make these ones much simpler. Okay. However, when we look at these nonmetals, they can combine with each other in multiple ways. So what I mean by that is carbon and oxygen can combine in this 1-to-1 ratio and make CO, which is carbon monoxide. Okay. They can also bond in this 1-to-2 ratio and make CO2, which is carbon dioxide. Is there a very large difference between carbon monoxide and carbon dioxide? Yes, right? One will kill you, the other one you absolutely need. Okay. So since they can bond in multiple ways, we can't just call them carbon oxide. Right? Would you agree with that? It would be too confusing. Okay. So when we write names and formulas for the binary molecular compounds, we use prefixes to differentiate between our different elements. And those prefixes tell us the quantities of which element is present. Okay. And then finally, the second element is going to be very similar to the binary ionics. It still is going to end in "ide." Okay, so like let's say we have chlorine. How is chlorine going to end? Chlorine becomes chloride. Okay. All right, so on the slide I have some prefixes. You do not need to write those down. Take a look at the backside of your periodic table where you have the naming chart. Okay. And then look at the bottom left. What do you notice is on the bottom left of that chart? Okay, the prefixes are on this chart for you. So again, you don't have to take the time to memorize that like 1 is mono, 2 is di, 3 is tri. You just need to remember to look for it at the bottom of your naming chart. All right, I have a couple extra naming rules. The first one, no double vowels of the same letter. So what I mean by that, if we have, like, let's say it's monoxide, so it's monoxide rather than monoxide. Okay. So if you have, like, two vowels that are the same letter, you just drop one of them. Also, on this rule, when I went to school, the rule was, like, no two vowels, but then that doesn't make sense, and the internet has a lot of info. So I also say, like, say it in your head, and whichever one sounds best is, like, the one you go with. And like if you go with that, like whichever one sounds better, you usually are on like the correct side of that line. And then our second rule is if the first element is a single atom, then you don't say mono. So for example, we have CO. If no subscript is written, what number is implied? Okay, 1. So if the first element is just single, like there's a 1 here, it's just carbon, not monocarbon. All right, we're going to do just a couple practice ones together. So our first one is CO. Again, if no subscript is written, what number is implied? Okay, 1. If it's the first element, we don't do a prefix. So what is the name of C?
Carbon.
Okay, so carbon. And then the second element, again, no subscript is written, so what number is implied? Okay, 1. For the second element, there's always a prefix. Okay, so what is the prefix for 1?
Mono.
Mono. Okay, and oxygen is going to become oxide. Okay, so then we just add mono in front of it, so it becomes monoxide. So this first one is carbon monoxide. All right, our next one is CO2. Okay. How many carbons are there? Oh, nope, if no subscript is written, what number is implied? 1. So do we have to use a prefix for that first element? No. So it is just carbon. And then how many oxygens? 2. What's the prefix for 2? Di. So now it becomes dioxide. So our second one is carbon dioxide. Our third formula is PCl3. Again, if no subscript is here, what number is implied?
1.
Okay, 1. So do we do the prefix for 1 if it's first? Okay, so what is P? Okay, this one is just phosphorus. Okay, and we grab that name just straight off the periodic table. And then how many chlorines? 3. So what is the prefix for 3? Tri, and then chlorine is going to become chloride, so it becomes trichloride. Okay. All right, so that third one is phosphorus trichloride. And then our last one is N2O. How many N's are there? 2. So what is the prefix for 2? Di. Okay. And then the first element, it is just the name on the periodic table. We don't change the ending. So what is N? So it's going to stay as nitrogen. So we're going to write dinitrogen. All right, and then the second element, again, if no subscript is written, what number is implied? 1. And then you always have a prefix for the second element. So what is the prefix for 1? Mono. So it'll be monoxide again. Okay, so dinitrogen monoxide. All right, so now we're going to look at how do we look at the name of a molecular compound and get the formula. Okay. This time, the prefix is just going to tell you what the subscript should be. Okay. So for this side, you probably just need to do the example with me. So in your notes, write down tetraiodine non-oxide. Okay. All right, so to figure out our formulas, again, we don't have to look for charges. We don't have to do crisscross rules. We just have to look at the prefix. What does the prefix tetra mean? 4. Okay. And then we look at the elements. So the element in this one is iodine. Okay. So it's just telling you there's 4 iodines. So then all you have to remember is when you write it, the subscript comes after the element. So it should be I4. And then we look at the non-oxide. Non comes from nana. So if you look at your prefixes, what number is nana? Okay, 9. And what element is oxide? Okay, so it's oxygen, and there's 9 of them. All right, let's take a look at sulfur trioxide. There's no prefix in front of sulfur, so what does that mean? Okay, there's just one of them, so it's just S. And then what does tri mean? 3. So, and what's the symbol for oxide? O, and then there's 3. So SO3. All right, and then phosphorus pentafluoride. How many phosphoruses are there? Okay, 1. And then what does penta mean? 5. And what's the symbol for fluoride? Okay, so this one is just PF5. The last thing we need to talk about are acids. There are, of course, more rules for acids, and we're not going to learn those rules. You just need to know the names and formulas for our 6 most common acids. And here's the good news. Take a look at the back of your periodic table on your naming chart. Okay. Take a look at the very bottom right. What do you notice at the very bottom right? Okay. I give you 5 of those 6 acids. You just need to add carbonic acid to your naming chart. So do you see how I put this one in red? Okay. This is the only one that isn't on your chart, so add carbonic acid. And then if your chart is like my chart, my sulfuric acid got cut off just a tiny bit in the subscripts. So make sure for sulfuric acid, you know it's H2SO4. Okay. And then these, you don't need to memorize, you just need to know that they're on your periodic table.